Hello, good morning, guys. So in the last class, we discussed about classful and classless subnet. And we did some examples for the classful and classless subnetting for class A, B, and C. Okay. And I also shared some practice questions in the drive. So is it clear about classful and classless subnetting? Any doubt in any question? Online people? Question number 4. Okay. A fellow engineer tells you to configure the DHCP server to list the last 100 usable IP addresses in the subnet 10.1.4.0/23. Which of the following IP addresses could be leased as a result of your new configuration? It's nothing. What you have to do, you have to make calculation for this. Okay. You have been given a class A with a /23. So all the calculations you have to do for /23. Once you do the calculation, you will get the IP range. From that IP range, you have to just check the last 100 addresses. Okay. And any address belong to that particular range, that is your answer. Okay. So see, let's say we have 10.1.4.0/23 have been given. Okay. So means how many network bits? 23. How many host bits? 9. Correct. So subnet mask would be the subnet mask. It would be 2. Let me first write in binary. 23. Okay. This is the subnet mask. So subnet mask is 255.254.0. This is the subnet mask. Now, if you see, if you design the networks, okay, according to /23. So in which octet there is a change? Third. In the third octet, how many host bits are there? 1. Yeah. So if you calculate third octet block size, so it would be number of host bit in the power of 2. So only 1. That is 2. Correct. Means your first network, if you start, that would be 10.1.4.0. Oh no, sorry, 0.0. Second would be 10.1.2.0. Third would be 10.1.4.0. This has been given to you. Okay. And next would be 10.1.6.0. So means your this particular network, okay, it is ranging from 10.1.4.0 till 10.1.5.255. Correct. Now in this range, if you calculate the last usable 100 IP addresses, so this is the network ID and this one is the broadcast address. Correct. So if you remove this, the last address would be something like 10.1.5.254 and just reduce 100 from these addresses because we have to just check the last 100. Means something would be 10.154. So just check if any address is falling in this range. 5. C would be the answer. Is it clear? Any doubt? Clear to everyone? Any more doubts in any question? Or all the questions were clear? Easy? Online people? Any doubt with any question?
No, sir.
No, sir.
Okay. Usram, you were having some doubt. Can you tell me? Okay. So we'll move forward. Now I'll tell you 2 methods to solve these questions. Okay. First method would be if you have been given /value and a IP. Generally, they'll always be asking you about network ID and broadcast address. But sometimes they'll ask you questions like what we have solved right now. Okay. They'll ask you, okay, from this particular network, which are the IP addresses we can assign? Okay. Kind of that. So like we have a question 10.7.99.133 and /24. Okay. So what you're going to do according to /24, if you check, what will be the subnet mask? 255.255.0. Correct. So you came to know that 3 octets are network and last octet is host. Okay. So just focus on the last octet. Now host octet, if you do it minimum value, that will be your network ID, and the maximum value, that will be your broadcast address. Okay. And 3 octets you have to keep same. So if you see which of the following is the resident subnet ID for the IP address 10.7.99.133/24. So obviously 3 octets same, and last part you do it 0. This is your network ID. Okay. Then which of the following is the resident subnet for IP address? Now you have been given an IP address with a /30. Okay. And you have been asked the network ID. Again, see here. The IP is 192. Yes, please. 168.44. 97/30. This is your IP address. So if you see /30 means again the change is in the fourth octet. So means first all ones 1 1, and here we'll be having 6 1 and 2 zeros. Okay. So in which octet there is a change? Fourth octet. Just check on the fourth octet, convert this into binary. So if you convert 97 into binary, what will be the value? 64 plus 32, 96 plus 1. Okay. Means your binary will be 0 1 1 0 0 0 0 1 3 3 6 8. Okay. So you now from this you can see how many ones are there? 6. So just keep the 6 constant. And if you set these two to minimum, that will be your network ID. So means this is my network ID. Because for host, I'm only having 2 bits, right? So this will be my network ID. If you calculate this in the decimal, what will be the value? 96. This is your answer. Okay. If you don't want to go like this, you can simply understand, okay, how many host bit we have? 2 host bit. We are having 2 host bit. So if you calculate number of hosts, so 2 raised to power 2. This is going to provide you the block size. So that is 4. So means first network you are going to design, that will be 192.168.44.0. Then we'll be having 4, 8, somewhere we'll be having 40, 80, and there will be a time we'll be having 96. And next will be 100. Correct? Now, this is your IP address. In which range it is falling? 96 to 99. So this is your network ID. Any method you can calculate.
So resident subnet means network ID.
Network ID. Basically, what does the subnet means? Resident you understood, I think. Okay. But what does the subnet means? Basically, we are having a network. This is, if you see, this is a class C network. But for class C, we were having /24. Now what we did, we designed a sub network. This is the subnet. Subnet in short, sub network. Understood? Clear? Okay. So in this way, you can make the calculations. And there is also a magic number method. And what is that magic number method? Let's say you have been given /30. So again, that method is going to provide you the block size only. So if you write /30 mask, what will be the mask? 255, 255, 255.252. Sorry. Okay. So the magic number is 256. Reduce your mask from this 256. Reduce it. 252. You got the block size 4. Now again, you can check. The first network ID will be 192.168.44.0. Then 4, then 8, 40, 80, 96, 100. Okay. So like this, you can use any method. The method does not concern. You must understand the concept. The answer should be correct. Okay. So any more doubts in any other question? No? Okay, then we'll move forward. So in subnetting, we are having a small concept, that is the FLSM and VLSM. Okay. Your FLSM stands for Fixed Length Subnet Mask. Means, what does it mean? Let's say we were having a /24, class C, default. So in class C, what we were having? Total number of hosts, 256. Correct? Now, when we did /25, what happened? We divided it into the 2 networks, 2 different networks of 128 each. Why? Because in case of /25, we are having host bit 7, 2 raised to power 7 is 128. So the networks we designed was, first network was having the IP 0 to 127, and second one was having 128 to 255. Not clear? Okay, see here. Yes, please. Let's say you have been given 192.168.0.0. So the first network would be 192.168.0.0, and second would be 192.168.0.128. This is clear. Now, if you see, for both of these networks, they were having equal number of IP addresses. First thing means their block size was same. Their block size was same. And what was the other thing? The subnet mask we were using what? /25 for both of them. Okay, means same subnet mask. So what happens in the FLSM? In FLSM, for all the networks, the subnet mask is same. Okay. So how do you decide a FLSM approach, and what is the problem with the FLSM? So if you see, let's say we are having 3 departments, IT, HR, and sales. So in your IT department, you are having 120 number of PCs. In your HR department, 60. In your sales department, 28. Clear? Now you have to design 3 different networks for them. Okay. So either what you can do, You can go with one network of class C, again one network of class C, different network, and one network class C. In one network, you'll be getting 256 addresses. Right now, I'm talking the default approach. We are not doing the subnetting. Okay. So if you see how many addresses you are going to waste from 256, you will be using 120. So what will be the wastage? 136, correct? Almost 196. And in this case, it will be almost somewhere around 218 or 238, 228. Okay. So this will be 228. This will be the wastage, correct? So there is a use wastage. To reduce this, we went with the subnetting. And in the subnetting, we are having two approach. One is the FLSM approach and one is the VLSM approach. So what happens in the FLSM approach? You are just going to check the highest number of requirement. In which department you are having the highest number of PCs. Okay, you saw that you are having highest number of PCs is where 120 in the IT department. So you will be calculating a slash value for these 120 systems. So if you see, when we are having /24, we are having 256 and there is a wastage. When we are going with the /25, it will become 128, correct? And when we are going with the /26, it is still going to be half 64. So in 64, can we meet the requirement of 120? No, means we have to choose what? /25. So once we have selected a slash value for the highest number of systems required in a particular department, the same slash value we are going to use in each and every department. Why? For easy understanding, easy configuration. Okay. So this is the FLSM approach where you use the same subnet mask for each and every department. In the FLSM approach, you are going to use the same subnet mask for each and every department. Why? Just for easy configuration. Okay. So that you don't have to remember each and everything separately. You remember, okay, we are having /25 means entire network is designed on /25. Okay. But in case of this approach also, still we are getting 128 addresses. In each and every department, we are using /25 means 128 addresses everywhere. Correct? So out of 128, you are using 120. What is the wastage? 8. Out of 128, you are using 60. What is the wastage? 68. Out of 128, you are using 28. What is the wastage? 100. So if you see, still we are wasting a lot of addresses. Okay, but for easy configuration, we can go with the FLSM approach. Okay, but the wastage is still high. So understood about the FLSM? You are just going to check in which department you are having the highest number of required host addresses. That particular same slash value, you are going to calculate a slash value or a subnet mask for that particular department. And the same subnet mask or slash value you are going to apply in each and every department, no matter what is the requirement. Okay, this is the FLSM approach. Next, we have the VLSM approach. So in the VLSM approach, we calculate a different slash value or a subnet mask for each and every department according to the requirement. Okay, so again, we are having three departments, 120, 60, and 28. So in /24, we are having 256. In /25, we are having 128. /26, we'll be having 64. /27, we'll be having 32. /28, we'll be having 16. /29, we'll be having 8. /30, we'll be having 4. Like now, check 120. Requirement is 120. So which is the best slash? 25. Okay. For 60, 26. For 28, 27. Because we cannot meet the requirement in 16, right? We need 28 addresses, and we cannot use 28 addresses when we are having only 16. So we need bigger slash, that is 32. But now if you check the wastage, because earlier we were having 128 everywhere, right? So the wastage was 8, same. Then we were having 68 and having 100. So earlier we were wasting total 176 addresses. But with the help of VLSM approach, how many we are wasting? 16. Okay. So this is the benefit of your VLSM approach. One more benefit is there. Let's say if you check, if I want to assign IP range in my according to the VLSM approach. So my first IP range for my IT department, I can assign from 0 to 127 because my block size is 128. And here I'm having 64 and here 32. Correct? According to the slash values. So in the first department, I can assign 0 to 127. Second department would be 128 to 191. And the third department, it would be 192 to 223. So I still have the addresses 224 till 255. I can still accommodate one more department in the same range. Correct? But what happens if we are using the FLSM approach? In case of FLSM approach, what is going to happen? Everywhere you are having 128 block size. Means in the first department, you'll be assigning 0 to 127. Second department, again, you need 128 addresses, means 128 to 255. Your network is complete already. While in case of VLSM approach, we were saving some addresses already. Clear? Any doubt in the FLSM or VLSM approach? So in the FLSM approach, for each and every department, the slash value or the subnet mask is going to be same. That is what its name suggests. Fixed length subnet mask means the subnet mask for each and every department is fixed. You decide one subnet mask, same subnet mask for all the departments. In the VLSM, variable length subnet mask means subnet mask varies from department to department according to the need. Clear? Any doubt in this part? Online people?
Sir, it could be.
No, sir.
But the FLSM, right?
Hmm.
It could be easier to configure actually FLSM, right?
Yeah, that's why there is a wastage, right? FLSM we configure for our easy understanding or easy configuration, so that we don't have to remember different slash values for each and every department. Okay, we remember once, okay, /25 needed, everywhere /25. That's it. Okay, but there is a wastage. Okay, so this is clear to everyone. Okay, the next we'll be having the introduction to the OSI model. Okay, so we are having certain models. One is your OSI model. Then we have TCP/IP original model, and we are having TCP/IP updated model. Okay, these are the three models in use. Okay, and right now only one model is being used, TCP/IP updated model. Means all of your networking devices, they are working on this model. They are being manufactured according to TCP/IP updated model. Okay, but we'll be starting with the OSI model because OSI model is the base thing for both of this. Okay, and to understand the network communication, OSI model is the good model. Now about these models, what are these models? Why do we require these models? So understand, OSI model is what, or any of these model is what? Just a set of documents. Okay, these are nothing, just the documents. And in these documents we have, or in these documents, certain protocols have been defined. Okay, and if you understand about protocol, what is a protocol? So protocol is set of rules. Means there are certain rules. And why these rules are there? These rules define how the network communication is going to happen, how your network communication devices are going to function. Okay, understood about this? Means your OSI model, TCP/IP model, they are going to explain how the network communication is happening, so that we can understand the network communication. And understanding the network communication will help us troubleshooting the issues, that where is the problem in the network. Okay. Yes, please.
Is the OSI the one that has the 7 layers?
Yeah, OSI has 7 layers. Yes. This is clear? Okay. Now, first of all, why do we require these models? Why do we need the OSI model? So what happened? If you consider the time during 1970s, when the network was just coming up in under development, you can say. So that time, each and every company were manufacturing their own devices. Let's say Dell is manufacturing their own devices. Okay, IBM is manufacturing their own devices. Okay, each and every company were manufacturing devices. Same like now, companies manufacture devices. But what was the problem? They were having their own set of protocols, that how their devices is going to work. Dell were having their own protocols, and IBM were having their own protocols. Okay, so if you had, let's say, if you had bought a Dell monitor, so that is going to function with a Dell CPU only, and Dell keyboard and mouse only. Means entire system has to be Dell. Why? Because the protocols designed by Dell, they were proprietary to Dell systems. Okay, so means these devices are going to function under a single vendor only. Similarly, IBM were having their own protocols. So their devices, if you want to design IBM system, then everything should be IBM. Otherwise, it is not going to work. Correct? So there was a problem, means certain, you can say there was a protocol war. Why? Because let's say I'm having a company and I have to buy some systems. So let's say I have bought some Dell systems, but at a later point of time, I want to expand my business and I find that IBM are good and a cheaper option than Dell. So I went with the IBM. Now there was a problem. These devices were not communicating. Why? Because Dell were having their own protocols and IBM were having their own protocol. So these devices were not communicating. So there was a problem. So in the year 1984, an organization, ISO, International Organization of Standardization, came up with the OSI model. Okay. And this OSI model, it brought standardization in the communication. Means some standard protocols were defined. And the ISO requested all the vendors, all the manufacturers to manufacture their devices according to the OSI model, so that there can be standard protocols that are supported in each and every vendor. Okay. Then the vendors started using the OSI model and started manufacturing their devices according to the OSI model. So finally, there was standardization. Means now Dell system and IBM, they were working on the same protocols. And now you can use a Dell monitor, HP CPU, Lenovo keyboard, like anything you like, they are going to work. But before, this was not possible. Clear? So understood why do we require the OSI model? Because before, in the earlier times, there was no standardization in the network communication. Each and every vendor, each and every manufacturer of the devices were having their own protocols, and they were not being supported by other vendors. So we were having a problem with the multi-vendor communication. Means HP was not communicating with Dell, Dell was not communicating with Lenovo, like that. Clear? Okay. So what is the OSI model and why do we need it? So OSI model is clear. What is OSI model? Set of documents, and these documents define the protocols, and protocols are the set of rules that define how the network communication is going to happen. Okay. Why do we need the OSI model? Because we need the standardization in the network communication. Okay. So OSI means Open System Interconnection. This is the full form. Okay. And it was developed by the organization ISO in the year 1984. Is that clear? Clear, right? Okay. Now we are having certain models. The three models I discussed. So one is your OSI model, one is your TCP/IP original model, TCP/IP updated model. These are the three models. So first of all, the early internet was designed on the TCP/IP original model. Okay. And the OSI model came up later, like in 1970s around, TCP/IP original model was under use. Okay. Then in 1984, ISO came up with the standardization with the OSI model. In the OSI model, you are going to find 7 layers: application, presentation, session, transport, network, data link, and physical. So earlier TCP/IP original model, it was having 4 layers. But see, there was a time when OSI model and TCP/IP original model, they were both in use. Okay. But right now, why your TCP/IP model is used and why not your OSI model is used? Okay. I'm saying that all the vendors are using now TCP/IP updated model. Why? Because they both were in use, but the development or updation of your TCP/IP model was faster and much frequent than the OSI model. Okay. And this was becoming more and more updated and more better. So finally, all the vendors shifted to TCP/IP model. Okay. And the OSI model, it became the reference model. Why? Because your TCP/IP model, the updated model, it is not defining all the protocols separately. Whatever protocols were defined in the OSI model, it is referring to those protocols. Instead of defining new documents for each and every protocol, it is referring to OSI model. And this is the reason your OSI model is sometimes called as OSI reference model. Okay, because your TCP/IP model, it is referring to the OSI model itself, instead of defining all the protocols again. Because the protocols that have been defined, they will be working the same way. So instead of doing all the work again, they just refer to the OSI model. Clear? So your TCP/IP original model, it was designed by the DoD, US Department of Defense. Okay. And your OSI model, it was designed by ISO in the year 1984. And your TCP/IP updated model, it has been designed by the ARPANET, Advanced Research Project Agency Network. Okay. This is the company, and it was developed in the year 2000s. And right now, all the vendors are using TCP/IP updated model. Is it clear? We are not using the OSI model anymore. But still, for understanding purpose, OSI model is the best. Because what is the difference if you see? So the difference is just that the top 3 layers, the name of the top 3 layers. In case of OSI, these are separate layers: application, presentation, session. But in case of TCP/IP model, this is one single layer, application layer. Okay, why your TCP/IP model says it is a single layer? Because all the tasks of these 3 layers, they are done by a single application software. So this is known as application. And remaining all layers, you can see they are the same. So if you want to understand the network communication process, then we can use the OSI model. And then same way, we can consider the TCP/IP model, because they are the same. Network communication protocols are the same. They are not changing. Means if someone has defined the IP protocol, the IP is the same, whether it is OSI model or TCP/IP model. They are going to work the same. Okay. The layer number, layer name, everything is the same. Clear? Okay. So these are the 7 layers of your OSI model: application, presentation, session, transport, network, data link, and physical. The numbering of the layers, it will be from bottom to up. Means your layer 1 is your physical layer, layer 2 is your data link layer, layer 3 is your network layer, layer 4 is your transport, session, presentation, and application. Clear? Okay. Now the top 3 layers, they are known as the software layers. Why? Because the entire task of these 3 layers is done by a single application software. One application is doing all these 3 tasks. Okay, and that's the reason in your TCP/IP model they just call it as an application layer. Okay, then the last 3 layers we call them as a hardware layers. Why? Because hardware devices are used. At your physical layer, hardware devices like your hub is used, your cables is used. At your second layer, layer 2, switches are used. At your layer 3, network layer, routers are used. So means at these 3 layers, we are using hardware devices. And this is the reason they are known as hardware layers. Then your transport layer, it is a connecting layer between the software layers and hardware layers. Or this is the layer where the end-to-end communication starts. Okay. And this is why it is known as the heart of OSI. It is using 2 important protocols for communication, TCP and UDP. And we'll be discussing these 2 protocols in detail. Okay. About layers clear. Now, on the sender side, when someone is sending the data, initiating the communication, the data will travel from layer 7 to layer 1, application to physical layer. Okay. And on the receiver end, it is traveling from layer 1 to layer 7. Okay. How? Let's see. So let's consider you want to send a message hi to your friend. You want to send a hi message to your friend. So how you are going to send it? You are going to use some sort of application, right? Whether it is SMS, it is mail, or it is WhatsApp, anything. You are going to use some application. Okay. Means ultimately you are going to load or deliver your data to the application. Then the application is going to send this data to presentation, session, transport, network, data link, and physical. Then entire world is connected. Anywhere you send the message in the world, it reaches, right? So entire world is connected through the cables, right? And cables are physical medium. So it is going to travel through those cables, reach to their country, and then go through the data link, network, transport, session, presentation, and they are going to receive the message in their application. Means if you are sending a message in WhatsApp from your phone, they are going to receive in the WhatsApp. Correct? So this is how the communication is happening. Means it starts from the application and end at the application. Clear? Is it clear? That on the sender side, when we are sending the data, we are going to put the data on the application layer. Correct? Then from the application, it is going to travel to the physical, and then through the physical media, it is going to reach there, and then again physical to application on the receiving end. Sender is going to send through the application, receiver is going to receive through the application. Clear? Any doubt? Online people?
No, sir.
Okay. Then one by one, we'll be seeing about each and every layer. So first is the application layer. So what is the application layer? See, this is the 7th layer in the OSI model and is user interface layer. Why we call it as a user interface layer? Because this is the layer that is going to provide us the interface, like WhatsApp. WhatsApp is just an interface, right? WhatsApp is just providing us an interface to send a message, receive message. Correct? So this application layer is going to provide you the interface. So we use certain applications like your Chrome, Firefox, your web browsers, your email clients. We use certain applications for starting the communication. Even if you want to send a message or make a call, still we are going to use a call application or SMS application. So anytime we want to start a communication, we are going to use a application. But one thing must be noted that the applications itself are not the application layer. Your applications, let's say WhatsApp. So WhatsApp is not an application layer. If you are searching on the internet, your browser is not the application layer. Your browser is using a protocol, because ultimately these layers are what? Defining just the protocols only. So your browser uses a protocol that is an application layer protocol. Okay. So your software applications, they depend on the application layer protocols to initiate the communication. They itself are not the application layer. Clear? So network applications use application layer protocols. Okay. Network applications use application layer to use different protocol service. Okay. Some examples of these protocols are FTP, HTTP, HTTPS, SMTP, and Telnet SSH. These 2 are used for remote access. SMTP is used for mail, HTTP and HTTPS for web browsing, and FTP is used for uploading and downloading of files, means file transmit. Clear? So let's say I want to search something on the internet. Let's say I will say just Google. Okay, I'm not typing an address. I'm just saying Google. So I haven't defined any protocol right now. Correct? If I hit enter, what happened? HTTPS. So what is HTTPS? This is an application layer protocol. Okay. So these applications, they are going to depend on these application layer protocols. So if these protocols are not there, they are not going to work. If the protocols are not there, then application is not going to work. Clear? So application layer is clear. Okay. So your application layer, it is the only layer that directly interact with the data from the user. Okay. If user has to input some data, they are going to put at the application layer. If they are going to receive the output, again, they are going to receive in the application layer. Clear? So this is the only layer that directly interact with the user. Next is the presentation layer. So what happens in the presentation layer? The presentation layer, it provides three basic facilities. One is the translation, second is the compression, third is the encryption and decryption. Okay. And it also decide format of the data. Okay. Because presentation layer, it mainly focus on the presenting the data. Okay. How the data is to be presented to the user. The main focus of the presentation layer is that. Let's say if I'm searching an image on the, if I'm searching for an image on the internet, so the output I'll be receiving is image. If I'm downloading an image from somewhere, I'll be receiving an image only. If I'm downloading a video, I'll be receiving a video only. If you see the network communication, it is happening through the wires, right? Can a music travel in wire? No, right? A signal is traveling. How that signal is getting converted back to the particular format? How the signal is getting converted back to the format? Your presentation layer is doing that. Your presentation layer, it is defining that format of the data. Clear? Okay. Then the basic tasks, translation, compression, and encryption, decryption. So what is the translation? So basically translation means if we have two machines ready, let's say two machines. Okay. They are using the different encoding method. Okay. For an easy example, let's say this is a Mac machine and this is a Windows machine. So for encoding the data, Mac will be using their own encoding method and Windows will be using their own encoding method. Okay. So if some data is coming from Mac to Windows, let's say you are sending a video from Mac to Windows. So you still can read the video in the Windows, right? Correct. Why? Because there is a translation of the encoding method. Just an example like ASCII and ABCD. These are two encoding methods. Okay. These are basically character sets. How the characters are going to be defined. Okay. So who is going to translate? Let's say Mac is, let's say I have a website that is hosted on the Linux server. I have a website that is hosted on a Linux server. Now I'm able to access it from the Windows also, Mac also, Linux also. And I see the same website. Why? Because there is a translation. There is a translation. Clear? Any doubt about the translation? Simply understand, if there are two machines that are using two different encoding methods, your presentation layer is responsible for providing the translation from one encoding method to the another encoding method. Then we have the compression. Compression means reducing the size of data. Okay. So your presentation layer compresses the data. Let's say you have given in high message in the application. That application is going to forward that message to the presentation. In the presentation layer, they are going to reduce the size. They are going to compress that data. Why? If we compress the data, the size of the data will be reduced. If size of data is reduced, means in less time I can transfer more data. Let's say my speed is 100 Mbps. Okay. So maximum data, how much I can transfer? 100 MB in 1 second. Correct. But what if I compress the size of this data to 25 MB? So now I can send 25 into 4. And each 25 MB inside containing 100 MB means ultimately how much data I'm transferring. Am I transferring 400 MB? So before in 1 second, I was transferring 100 MBs. Now I'm transferring 400 MBs. So speed of data, speed of communication increased. And I can also say my efficiency increased. So this compression is going to provide you two facilities, efficiency and speed. Clear? Then we have the encryption and decryption. Okay. So what is encryption? Encryption is basically changing your data, changing your readable data into unreadable format. Changing your readable data into unreadable format. Now, why do we require this encryption? Anyone? Security purpose. So that when your data is traveling from source to destination in the network, no one in between is able to read that data for data security, data privacy. Okay. So for that, we use encryption. So on the sending side, let's say you are using WhatsApp. So WhatsApp says end-to-end encrypted. Correct? So what happens? This is your phone and this is your friend's phone. As soon as you type the message in the application, at the presentation layer only it gets encrypted before even going to the physical layer. It is encrypted means on the sending side, the encryption has been applied. Now the encrypted data is going to travel and no one will be able to read that data. Why? Because it is unreadable. Let's say you said the hi message and it has been converted somewhat into like $1, $2, $3 star, something like that. It means an unreadable format, which cannot be understood. Then on the receiving side, when the data reaches the presentation layer, that particular presentation layer is going to decrypt the data and they are going to receive the message hi. And this is how it is end-to-end encrypted. Clear?
Here we use the SHA as method. And
They are the algorithms. SHA, MD5. They are the algorithms.
they are used in their
Yes. These are the encryption algorithms. Okay. We do not use, they are decided by the developer. Like in WhatsApp, we cannot change the encryption method, right? Why? Because that has been decided by the developer. Clear? So this is how it says end-to-end encrypted. So on the sender side, the encryption will be applied and on the receiving end, that encryption will be removed or the data will be decrypted back to original data. So presentation layer clear? Anyone having any doubt? No? Then we have the session layer. So now data has been encrypted. The hi message was there. It has been encrypted, compressed and decided format and everything. Now we have the session layer. So first of all, the session layer is going to do what? It is going to establish a session. Okay. And if we talk about session, so what is the session basically? When the communication start till the communication end. When the communication start till the communication end. Whatever the duration is there in between, that is a session. Okay. So means your session layer of the sending side, it is going to communicate with the session layer of receiving side. Okay. They are going to establish a session. They are going to say, okay, we can send the data. We can start the communication. Once the session has been established, the data transfer will start and the session will be maintained as long as the communication is going on. Let's say you are downloading a file from the internet. So until or unless that file gets downloaded, you are still connected to that server. And as soon as the download completes, you are disconnected from the server. Why it happens? Okay. So your session layer, what it does, it is going to establish a session, then it is going to maintain as long as the data transfer is complete. Once the data transfer is complete, it is going to terminate the session. Why it is going to terminate? To prevent the wastage of resources. Let's say you are using mobile data. Okay, and you are downloading a file, 1 GB file. Now your 1 GB is complete, but still you are connected to the server and your data is going. So means you are wasting the data. Your data is getting wasted, right? So your session layer is going to terminate the session. An easy example you can understand. Let's say you log into the bank website. Okay, you log into your internet banking. Now, once you log in, you are connected to the bank server. As long as you are working on that particular tab, as long as you are working in that particular page, your session doesn't get logged out. But once you switch to some other tab in 2 minutes, maybe 30 seconds, maybe 5 minutes, it will be automatically log out. Why? Your session will be terminated and you will get a message session expired. Please log in again. Okay. So session layer. Then also more tasks like authentication and authorization. Authentication means verification of the user. To log into the bank server, bank website, we need the username and password. Without that, we'll not be able to use the bank website. Clear? Then authorization is the level of access. We log into the account, but what is the access we have on that particular page or that particular website? Who is going to decide? The bank. Clear? So these tasks, authentication, authorization, and session establishment, maintenance, and termination, these are the tasks of your session layer. Is it clear? All right. Then this is the heart of OSI, the most important layer, transport layer. Okay. So transport layer is the layer where end-to-end communication starts. Okay. And for that purpose, it is using two protocols. One is the TCP, transmission control protocol, and one is the UDP, user datagram protocol. Okay. TCP is transmission control protocol, and one is the UDP, user datagram protocol. These are the two protocols. Okay. Now your transport layer, it has some tasks like segmentation, flow control, error control, connection, and connectionless transmission. Okay. And for each and every task of the transport layer, we are going to see a separate slide. Okay, we'll understand. Noted. First is the segmentation. So what happens in segmentation? Let's say you are sending a message hi to your friend. Okay. You are sending a message hi to your friend. Now your transport layer, just tell me one thing. Let's say you want to transfer 100 MB data. So is the 100 MB getting transferred all at once, or it gets transferred into pieces according to our speed, right? So in the same way, those pieces are done by this transport layer. Okay. And those pieces, they are known as segments. Okay. Your transport layer is going to break a big chunk of data into smaller pieces, and those pieces we'll call them as a segment. Okay. So let's say we have divided the high meshes like this into 3 segments. The high meshes we divided into 3 segments or 3 parts. Now we are going to transmit this. So once the data has been transmitted, the receiving side is going to receive these 3 segments, correct? But what if the exclamation reaches first, then reaches I, and then reaches H? Is it the correct data? No, this is not the correct data, right? So to reorder the data properly in sequence, your transport layer is going to attach an information that you call it as a sequence number. On each and every segment, it is going to attach sequence number. It is going to say this is the first segment, this is the second segment, and this is the third segment. Now sequence number have been attached. Now the receiving side, in any order they receive the data, according to the sequence number, they are going to reorder the data, and you will get the correct message. This is clear? Okay. But now again, there is a problem. What is the problem? Let's say you sent that message in the WhatsApp. So how your receiving end is going to decide where or in which application the data should be displayed? Because again, it is traveling in wires. Wires cannot decide which application. Wire is what? In wire, it will be just traveling in the form of 0101 form, binary form. Okay, this is clear. So how they are going to decide? So for this purpose, your transport layer is going to attach one more information, that is the port number. Okay, so what is the port number? Port number, you can say simply entry point of the data, or your port numbers, they make sure the data gets delivered to the correct application. Okay, these are the logical port numbers. Okay, from 1 till 65,535. These are the port numbers. Out of these port numbers, your 1 to 1023, they are reserved. Okay, or they are known as well-known ports. You might have heard that your HTTP service works on port number 80. Your HTTPS works on port number 443. Your DNS works on port number 53. Okay, correct? Your SSH port number 22. Telnet port number 23. So they have been assigned some protocol, port numbers. So means if the data is for port number 80, means we will know it is HTTP traffic, means we have to display it in the web browser. If it is 443, means HTTPS, again browser. If it is port number 25, means SMTP, means email application. This is how your correct application is decided based on the port numbers. Is it clear? So your transport layer is going to break the data into segments, and on each and every segment, it is going to attach sequence number and port numbers. Sequence number is going to help you reorder the data in the correct sequence. Port number is going to make sure that your data gets delivered to the correct application. Okay, segmentation clear? Online people?
Yes. Yes.
Okay. Next, we have flow control. So what is the flow control? Basically, we are controlling the flow of data. Okay. So how do we control the flow of data? Let's say you have a system that has the maximum speed of 100 Mbps, and you have a phone that is having the maximum speed of 10 Mbps. Okay. So your system, it can send data at the maximum speed 100, but can your phone receive? Cannot receive. So what will happen if system starts sending data at 100 Mbps? What is going to happen? The data will come here and just, because in 1 second it is going to receive only 10 MB. Rest of the 90 MBs, that is going to stay in the buffer. And there will be a time, because each and every second it is going to send 100 MBs. Correct? So there will be a time when the packets will start dropping. Okay. So your transport layer of the receiving side is going to tell, or is going to give a message to the sending side that I cannot receive so fast. Slow down the speed. Okay. So your sending side transport layer, it is going to slow down the speed, and they are going to find a speed that is sufficient for both. Means the speed at which data can be transferred without losing the data, without dropping the packets. So means like your 10 Mbps. So your transport layer is going to reduce the speed of communication. Clear? Similar way, let's say if this system is sending too slow, like 5 Mbps, and it can receive 10 Mbps. So it is going to tell, I can receive more data. Please send me faster. Then it is going to increase the speed of communication. Clear? So this way, the method of this increasing or decreasing of the communication speed, this is called as the flow control. Means basically you are controlling the flow of data, that how much data should flow on the network, so that no data or no traffic or no packets are lost. Is this clear? Next, we have the error control. So what is the error control? Let's say this is your high message. Okay, you have sent the high message. Now the first segment reached there. The second segment somewhere lost in the network. Okay, dropped due to any reason. And the third segment was reached. So it is having the sequence number 1, correct? 1, 2, and 3. So your receiving side is going to check, this is 1, this is 3. Means something is missing in there. Something is missing in there. So it is going to tell the sender that I haven't received 2. Please retransmit. So it is going to retransmit. And once retransmission done, they are going to have the complete data. Is it clear? This is how they detect the error and remove the error. Understood? Now, there is one more situation when the data packet gets corrupted. When the data gets corrupted. So how does your systems know whether the data is corrupted or not? See, in each and every segment or each and every packet, they will be having a value called as checksum. Okay, what is this checksum? Let's say this is your high message. Okay, so they are going to run some algorithm or some maths on this data, and they are going to calculate a value. Let's say that value came out to be 1, 2, 3. And the sender is going to attach that value with the data itself. So when the data reaches the receiver is going to do what? It is going to run the same algorithm. It is going to run the same algorithm on the data. And whatever value calculated, let's say if the value is 123, 123. Okay, so it is going to confirm, verify with the value sent by the sender. If the value is same, means data has not changed. And if this value came out to be 456, and it is going to compare with the sending side value, they are not the same, means the data has been changed in the transit, and means this data is corrupted. So your receiver is going to drop the corrupted packets. Okay, and then it is going to ask for retransmission, that this particular packet I haven't received, retransmit. So this is how they control the errors. First of all, if a packet is missing, they are going to ask for retransmission. If a packet is corrupted, they are going to drop the packet, then ask for retransmission. Clear? Any doubt? Online people?
Yes, clear.
Drop the packet in the sense the data will get dropped, or only that particular packet?
That particular segment. The particular segment that is corrupted, that will be dropped and it will be asked for retransmission. Then we have connection and connection-less transmission. So right now we discussed about, I told you that in your transport layer, we use 2 protocols, TCP and UDP. So all these tasks like your flow control, your error control, okay, these are the tasks of your TCP. And your TCP, it is known as your connection-oriented protocol. Okay, why it is known as connection-oriented and why it is having these features, flow control, error control, how this exactly happens. These things we'll be studying in our next session when we'll be deeply discussing about TCP and UDP. Okay, and your UDP, it is connection-less. So in a simple example, I'll just say that when we are using TCP, so you get confirmation for each and every segment. Let's say you send segment 1. The first segment you say, this is the sender side and this is the receiver side. So you send the first segment, receiver is going to say, okay, I have received the first segment. Then it is going to send the next segment. Again, there will be a confirmation from the receiver. For each and every data packet, there will be a confirmation. Understood? But in case of UDP, what happens? Once you make a request, they are going to flood the information. They will not listen to you whether you want to receive or not. They'll just keep on sending the data. Okay, understood? So this is why it is connection oriented and connection-less. This is just a simple example. Tomorrow we'll be discussing TCP and UDP in detail. And we'll be discussing that in your TCP, we have something called as 3-way handshake. And in your UDP, we are not having anything like that. Clear? So this is about transport layer. TCP and UDP, tomorrow we'll be discussing in detail. Then we have the network layer. So at the network layer, we mainly focus on the logical addressing, routing, and path determination. Logical address. Give me an example of logical address. IP address means we'll be making use of the IP address. So IP address is which layer information? Layer 3 information. Understood? Now, with the help of this IP address, we are going to send, or there will be a device is used, router. Your router is used at layer 3. So the task of your router is routing. Routing means sending a data packet from one network to another network, providing communication between two different networks. Okay. So your router is going to send the data packet from one network to another network. Is it clear? Then there's one more thing, path determination. So what is the path determination? Let's say this is Bangalore and this is Delhi. How many possible paths are there for going from Bangalore to Delhi? Okay. Let's leave the number of paths. Let's say transportation method. You can walk. There is a possibility. You can use cycle. You can use bike. You can use car. You can use train. You can use bus, or you can use flight. These many options are there. But which option you are going to choose? Depending on each and every person, there will be a different. Maybe some people prefer to walk, or maybe some people prefer by car or train or flight or bus. Depends person to person, right? Every person is going to have their own criteria to compare the paths, the ways that how we can reach from source to destination. Ultimately, source is same, destination same, but the way we reach them, that is the different. Correct? So how do we choose the best one? We have some comparison. So this path determination, that how your data is going to travel from source to destination, that will be decided by your network layer, means by your router. Okay, router is going to decide how your data packet is going to travel from source to destination, which path it is going to take. So the path will also be decided by your network layer. Is it clear? So logical addressing, routing, and path determination. Any doubt in the? No doubt. So network layer is clear. Okay. Online people, any doubt in the network layer?
So OSPF and BGP, these all are the types of path determination.
These are the type of protocols. Okay, we have certain ways to define the paths. So there are two manual ways. One is the static route. One is the default route. Then we are having dynamic protocols, dynamic routing protocols. So in the dynamic routing protocols, there are certain protocols like RIP, IGRP, OSPF, ISIS. Then we are having EIGRP and VGP. These are the certain protocols we have. Now your RIP, it is not being used. IGRP is also obsolete, not being used. Okay. OSPF we are having in our syllabus. ISIS, EIGRP, and BGP, they are in your CCNPs. Okay. But I'll be showing you some introduction about the RIP as well as EIGRP also. Okay. So you can have basic knowledge about them and you can have basic configuration. I'll be doing a lab also on RIP and EIGRP. Okay, so these are the protocols. So these protocols, basically, these are just the ways to define the path from source to destination, that how your data is going to reach from source to destination. So similar, like, let's say we just saw an example, like we can walk, we can use a car, something like that. So we are having certain methods to decide the best path. Okay, so which path we are going to use, that will be dependent on these protocols. Clear? Then we have the data link layer. In the data link layer, the first term is the framing. Okay. So what is framing? Again, if you see at the transport layer, the data was broken into segments. Correct? Now, when the data reaches the network layer, at the network layer, it will be further broken down into packets. So packets is the term used at the network layer. Then when the data reaches the data link layer, it will be known as a frame. So what is the basic difference between segment, packet, and frame? Understand. Application layer, starting of communication. I gave in the data, hi. Went to the presentation and session, because still it is in the same application, so it is going to remain high only. Okay. So until session layer, this message is going to remain high. At the transport layer, it is going to be broken down into three different segments. Okay. One is your H, one is your I, and one is your exclamation. Now, your transport layer, it is going to attach some information, that is your sequence number and port number on each and every one. Sequence number, port number, sequence number, port number. Okay, so this particular one entity, it is the segment. Clear? Now I'm just taking example of one single segment. This segment travels to the network layer. Now network layer, it mainly focuses on the IP addressing. Correct? So means you message H with the sequence number, port number. Now your network layer, it is going to attach some information, that is the source IP and destination IP, from where the data is going and where the data is going. Okay, who is the source and who is the destination? That information is going to be attached by the network layer. And this one entity, it is known as packet. Okay, now this packet is going to travel to the data link layer. At the data link layer, I'll just call it as packet only. Okay, single entity, I'm counting it. This is your packet. So with this packet, it is going to attach the information source MAC and destination MAC, because MAC address is layer 2 information. Okay, and your switches does not understand the IP address. So it is going to attach the information source MAC and destination MAC. And then it is also going to attach a trailer, that is FCS, frame check sequence. What is this FCS? Again, it is similar to checksum. Means your sender is going to run some algorithm on the data. They are going to put that value in the FCS field. Once the value is there in the FCS field, it is going to be sent on the other side. The receiving side data link layer is going to run the same algorithm on the data, and whatever value is calculated, it will be compared with the FCS. If it is same, means data has not changed. If it is different, means data has changed in the transit. Okay, and if it is changed, means the frame has to be dropped. Okay, so it is going to attach the header and trailer. So this process of attaching header and trailer, first of all, this one entity, it is your frame. This one entity, it is your frame. So you see at transport layer, network layer, and data link layer, we are attaching some extra information with the data. Okay, so if you attach some information in front of the data, okay, in front of the data, if you attach it, this is called as header. And if you attach at the end of the data, it is known as trailer. Okay, and this process of attaching this information, it is known as encapsulation. So what is encapsulation? Attaching some extra information with the data, that is encapsulation. Clear? Okay, so framing is what? Creating frames from the packets. You received packets from the network layer, then you broken down, or you attach some extra information with the packet, and you created a frame. So the process of creating frame from your packets, it is the framing. Okay, then in this we have the error detection. How the error is detected? Through the FCS field. Okay, comparing the FCS field, we can detect the errors. Then direct the frame to the correct destination on the base of MAC address. If you remember, the switch has a MAC address table, right? On which port, which MAC address is connected. So looking at the destination MAC address, your switch is going to decide whether on which port we have to forward the frame. Clear? Online people? Any doubt in this?
So suppose somebody is sending me a message,
Mhm.
and after network it is reached to the switch.
Mhm. Okay.
So switch is going to add that information to
Which information?
like MAC address and destination source MAC address.
It will be attached in the, like what you're saying. Repeat your question.
So how the source and destination MAC address information is attached to that packet.
This packet will be encapsulated at your sender, the sending application. Okay, like you are sending. So in your systems, you are having NIC cards, right? And NIC cards are using MAC address. So they are going to encapsulate this information there. Okay, because your PCs, they are also going to have ARP cache. I'll show you how the entire communication process happens, like how your switch makes all the forwarding decisions and all. We'll be capturing the packets and we'll seeing the information. Okay, so your system, it is going to encapsulate the information. Your switch is just going to check the destination MAC address, and it is going to forward the packet. Switch is not going to encapsulate your packets. Your packets will be encapsulated into your device. Okay, is that clear? Any more doubts? No? Then we have the final layer, that is the physical layer. So in the physical layer, we are just using the cables, right? We are using the cables between the sender and receiver. So in the cables, so to transmit the data into the signals, first of all, what we'll be doing, like let's say your data has been converted into bits. First of all, the task of your physical layer is converting data into the bits. Then that particular bits, it is going to convert in the signals and load onto your media, means load onto your cable, whether it is copper cable, fiber cable, or wireless media. Whatever media is there, it is going to convert it into that particular signal. Then through that particular wire or media, the data is going to travel, and on the receiving side, it will be converted back into the signals. And from the signals, it will be converted back into the bits. Once it has been converted back into the bits, the reverse process will start. Okay. So what will be the reverse process? Let me explain. So if you see, the media can be copper, fiber, or wireless. Okay. So in case of copper media, you will be sending electric signal. In case of fiber media, we will be sending light signal. And in case of wireless media, we'll be using radio waves. Okay. We'll be using radio waves. Clear? So these are the media. Is it clear? Now we'll see the entire process all at once, that how the process is happening. Noted? See, now let's consider you are sending a message hi to your friend. Okay. So you gave the message in the application. From application, presentation, and session. At these three layers, it is going to remain the message hi only. Okay. Then at the transport layer, it will be converted into the segments. Your data has been converted into a segment. So this is the segment. Okay. And with this segment, sequence number and port number information has been attached. The segment has been forwarded to the network layer. At the network layer, destination IP and source IP will be attached. And this particular information, it is going to be known as packet. Okay. Then this packet is going to travel at the data link layer. At the data link layer, FCS will be attached and source and destination MAC will be attached. And this entire information, we will call it as a frame. Now, at the physical layer, first of all, it will be converted back into the bits. And these bits will be loaded onto the media. Okay. By converting into electrical, light, or radio waves. Once it has been loaded onto the media, it is going to reach on the receiver side. On the receiver side at the physical layer, so converted back into the signals and into the bits. These bits, they are going to travel to the data link layer. So at the data link layer, first of all, the receiving side data link layer, it is going to check the FCS field. It is going to check for the information, run the algorithm, and check for the FCS field. Okay. So if the FCS value comes the same, whatever algorithm they run, if the FCS field is the same as the new value, then the data has not changed. And if it has changed, it is going to drop the information. Okay. And whatever information was attached on the sender side, let's say FCS was attached. So on the receiver side, this information will be removed. This information will be removed at the data link layer. And the remaining information, the packet information, that will be sent to the network layer. At the network layer, they'll check whether source and destination IP means it is for the receiver or not. If it is for the receiver, they are going to remove this information. Okay. Then the segment, they are going to send to the transport layer. The transport layer, it is going to wait for some time. Okay. It is going to wait for the buffer to fill so that all the segments can come, then they can be reordered and then given through the correct application. So once at the transport layer, all the data has been received, reordered, it will be delivered to the correct application. Okay. And they'll be receiving the message hi. This is the entire process that happened. So on the sender side, the information is attached. This is encapsulation. On the receiving side, the information is removed. This is de-encapsulation or decapsulation.
So this are all exercises are done by certain protocol rules,
All protocols.
deciding in particular layer.
Yes. Okay. These are all these tasks are done by the protocols only. Okay. We'll be studying certain protocols, layer 2 protocols, layer 3 protocols. We'll be studying them. So any doubt so far? No? Online people?
No.
Yes,
Where
please.
are these protocols actually saving the router of the PC or the device?
Hmm?
Distributed among all the devices.
Yeah, because at different layer, we are having different devices, right? Router is a layer 3 device. So router is going to support layer 3 information, means the protocols that are used at layer 3, like your RIP, OSPF, BGP, all these routing protocols, IP. Okay. So protocols have been divided because according to these models, at each layer, we are having certain protocols. According to those protocols, only manufacturers are manufacturing their devices. And that's why we can say switch is a layer 2 device. Hub is a layer 1 device because they are designed like that according to the layers. Is it clear? Okay. So I'm done for the day. If you are having any doubt, you can ask me or I'll stop the recording. And guys, before leaving, just let me mark the attendance again because I think new people have joined.